It's my great pleasure to be here, and it's really awesome just to listen to Kim talk about the AI. Right? So there's a very interesting science fiction series. Right? So it says that probably potentially some of the new technology could be sent back to today by a human in the future. So AI and deep learning, probably one of them, to help today's human to release ourselves, because with deep learning, the computer can now, AI can help our human to do a lot of things. However, it has this kind of problem that we are all worried about today. What if the good guys use AI to do this stuff for the human? That's great. What if the bad guy hack it? What if the bad guy control the AI? So that could be a potential big problem. And there's another technology that is potentially sent back to the today by the future human, which is blockchain. So what blockchain is, blockchain could potentially to build a trust in the trustless environment. And today I'm going to give a talk, I call this blockchain demystified. Because today, whenever people talk about a blockchain, it's always about cryptocurrency. But my talk is mostly focused on something that is not related to cryptocurrency. Before I start, I would ask a question. How many of you have owned Bitcoins? Awesome. Well, so in most of my talk in the past 1 year, it's like over 50% people have cryptos. They're all interested about the crypto. They ask me the price. However, I can only answer the question about the technology. So this is starting part is something like a blockchain 101. So if any of you have any questions, feel free to stop me. And so what exactly is blockchain? Interesting story is today there's actually no clear definition of what is blockchain. So in year 2008, Satoshi had this white paper, Bitcoin white paper. So the goal he's trying to solve is try to invent a peer-to-peer money. Basically, you'll be able to let two peers transfer some kind of digital money without a third party. So blockchain happened to be one of the data structure when he wrote the code, when he invented the code. So right now, it has been 10 years has passed. So the blockchain technology has been involved in several generations. So let me give you a brief introduction of what the generation looks like. So the blockchain 1.0 apparently is from the Bitcoin, right? So what essentially is a blockchain? In the blockchain, it's basically a distributed ledger. So essentially, when Satoshi tried to solve this problem of be able to send send money from peer to peer. So the biggest problem he need to face is first is the ledger, right? How to make sure the ledger is immutable. What if somebody try to hack it and change it? So he basically used a very brute force way. So basically the ledger has been copied and more heavy nodes. Imagine that if today everybody in this house, we're going to keep a ledger. So the simplest way is if I say I borrow I give $1 to this gentleman here. If everybody write down this in this ledger, and then in this whole clause we reach the concept that I give $1 to this gentleman. If some of them try to change the ledger, but because most of the people here already know this fact, it's really hard. So the only way is if I can persuade over 51% of the people modify the ledger, and then actually, unfortunately, the fact has been changed. Right? However, in the reality, this is really hard. So essentially, Satoshi in Bitcoin is basically have this kind of distributed ledger that is run by many nodes. And why those nodes want to keep this ledger for them? So in the beginning, I'm one of the nodes. In year 2009, I'm very interested in all this kind of new technology. Where at the time I worked in Microsoft Research. I see this white paper, I see this Bitcoin concept coming up, feel pretty interesting. So I have one free server. I basically download the Bitcoin 0.9 or something and run it. And it's very easily, I can mine a few blocks. At the time, each of the blocks is 50 Bitcoins. I guess I probably mined about 45 blocks, which is I got 200 Bitcoins at the time. it was $2 million a couple of months ago. But guess what? I just formatted this after I did the experiment. Because of time, I think, okay, this is an interesting technology, but this is money? This is worth anything? No way, right?
That's why you're here.
Wow. Yes, that's a very interesting lesson. And but why mine the blocks? The Bitcoin going to give you this kind of Bitcoins, right? So that's called the incentive. Right? So if you are just like me at the time, I'm just curious and interested, try to run a node to keep this ledger. It's not going to last, right? I just mine 4 to 5 blocks and then I shut down the computer and the ledger is gone, right? So, but for those people who think if those kind of Bitcoins make sense to them, it could be something valuable. So that's kind of the incentive for them to keep running the nodes. So the more people keep running the nodes, the ledger gets distributed more widely, and then it's much harder for people to attack them, right? So that's a whole logic behind the Bitcoin. So the Bitcoin concept it's quickly become pretty popular in the geeks, and so there's tons of people beginning to use Bitcoin to transfer something. So notably, one of the gentlemen, I think that's in year 2012. So he had the first transaction in the world. He used 10,000 Bitcoin to buy 2 pizza. So that basically that pizza is worth kind of hundreds of $millions eventually. Right? So he learned a much bigger lesson than me. So in around year 2013, right? So the Bitcoin has been used in some kind of black market and also in those kind of money laundering. So Bitcoin has its values over the world, right? But then in year 2013, there's a big crash of the Bitcoin price crash. The price crashed a lot, and then again, a lot of people beginning to think, shoot, this technology is just for geek. It's not really some kind of useful money. But for quite a bit of those geeks, they're really dedicated to this technology. They think the technology definitely can be useful. So they began to think, what if we can use this kind of technology not just for the cryptocurrency? What if it can use it for something else? So that's come to blockchain 2.0. So in blockchain 2.0, is those engineers began to think, if we're not using this ledger not only for logging the transaction of this kind of cryptocurrency, we also use that for some kind of let's say some structured data. What if this structured data can be represent some kind of asset? Right? It can be represent a house, represent some kind of share, represent some kind of gold. Or what if we use this ledger to store some code? So the code can have some computational logic. So if there's some contract between people, so the contract can be recorded in the blockchain. So it's immutable, it's open, and it's whenever those contracts get executed, it's always get the consistent result. So this kind of become blockchain 2.0, which is represented by the smart contract. So one of the very important players in this space is Ethereum. So essentially Ethereum was built by Russian hackers, and he had this concept, try to build a called world's computer. So the idea is try to build the computing engine on the blockchain. So in the blockchain, there's not only just this ledger of transaction, but also a lot of this code. With this code, it's basically become a computer, a supercomputer that nobody can shut down. It's the same as a ledger, but it's just running a computer. And a lot of people are going to kind of run this computer together, and it's going to be able to do a lot of interesting things. So I'm going to explain a little bit what is the most successful application around Ethereum later. So recently, there's a new wave, mostly starting from last year. We are actually one of the players in this wave. Is we try to evolve this blockchain into 3.0. So because when we try to put those code in the blockchain 2.0, eventually people realize there's a bunch of issues. So first of all, is actually is not everything can be put in the blockchain. So usually blockchain, smart contract, is just kind of a solve part of the problem. To be able to solve the complete problem, you might need something more than blockchain itself. So blockchain 3.0 is mostly focused on building a platform that can take advantage of this kind of distributed ledger technology that can become an application platform. In this platform, we can do a lot of interesting stuff. Imagine it's kind of like a cloud computing, it's like the AWS, but for building this kind of trusted applications. And also, during blockchain 1.0 and 2.0 age in the last 10 years, there's many different companies trying to build different things because in the very early stage, a lot of smart people think about an interesting new method. So if you look at those coins, there's Bitcoin, there's Litecoin, there's Bitcoin Cash, there's Doge coin, there's hundreds, thousands of different coins. Each of those different coins might also include a different kind of blockchain technology behind it. So if you today try to do something, you're really going to get confused because there's too many different kinds of technologies. They all called blockchain. And as I mentioned, blockchain, there is no definition of blockchain. So just there are too many things. You don't know what to do. So to be able to build this kind of application, we really need something that has this kind of open standard that people can follow some kind of certain rules or follow some kind of certain models to do it. So this is basically a quick overview of how the blockchain technology you go from the 1.0 to 3.0. So what blockchain can do, right? So of course, everybody knows that blockchain can be cryptocurrencies. So basically, for the 1.0 blockchain, for example, let's say Bitcoin. So Bitcoin is a blockchain called Bitcoin. This has one of the protocols, like Bitcoin protocol, and it will only run one application for Bitcoin. So Bitcoin is a blockchain, it's also a protocol, and it's also an application. So in the very early age, all those blockchains, almost all those blockchains, they actually only designed for one specific purpose. So in the big, if you look into this blockchain space, you probably always heard about the word fork, right? So the fork chain. Why people fork? Right? Because in the very early age, Bitcoin is only designed for Bitcoin itself. So whenever people want to kind of change something, they basically fork it. So they change some parameters. Probably some of those coins just change a little bit parameter. Some of them probably make big modifications. So it's kind of a different kind of versions, revisions of the Bitcoin technology. So as we mentioned in the 2.0, 2.0 is basically people try to do something more than cryptocurrency itself. So the first movers in the blockchain 2.0, I would say that should be the color coins. So what is color coin? So color coin is basically taking, did you see some of those kind of advertising? People put that in the $1 bills. So in the bill they put the advertising. So basically, when they put this advertising on those kind of bills, is actually give some kind of interesting value for these bills. So this is a dollar bill. So it has all those kind of features of a dollar bill. It has its value. It's very hard to replicate, but it also kind of colors. It also has some other stuff. It could be some kind of advertising. It could be some kind of let's say I can also use a $1 bill to create a contract, which is really hard to copy because writing something on the bill is very easy, but the bill itself has all those kind of high-tech protection technology by those banks. Right? So the first generation of the blockchain application they try to build is called color coin. What it does is they put the Bitcoin. Each of the Bitcoin it has on the transaction it has a field that you can put whatever data you can put there. I think it's 40 bytes. It's very tiny. And those hackers, they're putting those kind of structured data into that 40 bytes. So use those kind of data to represent something. Let's say, for example, they use this kind of one Bitcoin to represent a stock or a certificate of the, let's say, a certificate of a stock or a certificate of a graduation or diploma. So this is a very early stage the usage of the Bitcoin. So with this kind of color coin, you basically it's completely built on the Bitcoin. So if you get this kind of value of Bitcoin, it's very hard to manipulate. It's immutable, and it can support transfer peer to peer. So this technology is called color coin. So actually, it's fortunately at the time in Microsoft, I have a colleague, Claudio Chellan. He is one of the guys who is the pioneer of the color coin. So if you look at the Wikipedia about color coin, it's almost all about him. So at the time, he was my colleague in Microsoft Europe. So there's an interesting story about him too. So at the time, because Bitcoin does not worth any money, right? So he ran those tests. He used 0.1 Bitcoin for the test. So every time he run a test, he's basically going to consume probably 1.1 Bitcoins for every run, right? He probably, when he ran the test, he probably wasted like hundreds of Bitcoins because he at least run those tests for thousands of times. So a few years later, he reminds that, oh, it's so expensive to run those tests because every test is basically cost like $1,000 at least. So since the color coin is kind of hacked, you can only put a little bit structured data on those kind of field. It's not very flexible. So that's why Ethereum is coming out. So basically, Ethereum is a virtual machine. So it calls itself a fully complete machine. It's basically a programmable language. You essentially can do anything there, right? With Ethereum, so since it's a virtual machine, technically it can do anything. But however, right now, the most successful Ethereum occasion is called ICO. How many of you know ICO? So ICO basically is called initial coin offering. It's kind of a crowdsourcing. It's kind of a funding method, similar to crowdsourcing. Because U.S. government and many of the government think crypto is not the money. It's a digital asset, right? So basically, if I have some assets, you have some great ideas, so potentially I can give you some of my assets to you to exchange some of the digital assets you create in the future. So that's kind of build a kind of new way to funding new project. So the Ethereum eventually become the most successful platform for all those kind of new technologies to get funded by this kind of by building this ICO smart contract. So when it comes to 3.0 technology, so there's a lot of white space open here. So I can see quite a bit of things. First of all, it's kind of a blockchain together, married together with cloud computing. Because in the past, blockchain is still mostly the machines are running in this kind of mining farms. They're probably running something in the garage, running somewhere in the near a village because when the electricity is cheap. But in the future, when the blockchain becomes an infrastructure for the banks, for the whole society, and potentially for the military, you can imagine the node is running by a hacker, right? So the big trend is could be this could be something that is running together with cloud computing. The other important part is since there's going to be a lot of different blockchains, so be able to access to different chains with one application becomes really important. So the cross-chain access becomes something really valuable. And also because the blockchain is open ledger, so the applications on top of those ledger could be the data analytics. Imagine that today there's a lot of people doing bad things with Bitcoin, with Ethereum, by doing the money laundering. But guess what? All those kind of data is actually public. The only thing is people are not that easy to access this data, but all those kind of transactions is actually public. People can actually visualize the data from the blockchain, from the Bitcoin and the Ethereum, to be able to understand the inside out of the detail of all those transactions. Here's a framework I took from one of the very nice articles. If you were interested, you can read that article. So basically, when to use blockchain in system design. Right? So blockchain, from my point of view, blockchain is not something like for everything. Right? It's blockchain technology in a system architect point of view, I think its position is very similar like a database. Imagine today, 99% of the applications are actually database-centric applications. But imagine that when you build an application, database is not everything. So there's still tons of things that is off the database. There's some of the data and some of the logic on the database. But most of this kind of application logic is off the database. You basically, when you build a database application, is basically you try to building a system that has the on the database and the off the database together, working together to become an application. This is something very similar to the blockchain. So the blockchain, as the typical architect, as I imagine, is something that you have something that you need to take advantage of the blockchain, so that it is on-chain logic. And it also has the off-chain logic that work together with that to providing a full system. So, because of time limitations, so I cannot explain every detail of those components. Actually, these two slides, I can definitely spend each of the slides can spend 1 hour on it. And I also give two of the examples. So what blockchain can do, right? So this is one of the typical examples for the for a typical data sharing scenario. Imagine you have multiple different parties. Each of the parties need to share some of the data. Some of the data are really critical. They probably need to have some security clearance. And each party might not necessarily to have all the everything of those data, but and maybe this data is also not controlled by one party. And this could potentially this kind of data sharing scenario is very popular in the insurance, in the supply chains. So with the blockchain, you can potentially use blockchain technology to control the privacy, control the data access to all those pieces of data. And you also can use blockchain to log everything. Who has the access to what kind of data, who authorized the data. So this is become a typical framework for multiple parties to share critical data and with the secure way, and also everything is audited, and nobody can easily change. Nobody can easily make some kind of nobody can easily manipulate and change the access right. Another typical scenario is this kind of data marketplace. Imagine in a bin store, some of the data they're really valuable. So different parties they could potentially negotiate on different terms. And today, if you in those data market, it's all about business. People are talking to each other. But in the future, what if those data they have these rules? Those rules can become smart contract. And so negotiation on those data marketplace, and to be able to how much data you consume, how you can contribute data back, it's all kind of built with this kind of incentive plan that's controlled by a smart contract and built on the blockchain. So there is no longer need for different parties to negotiate a lot of things anymore. So I'm running almost out of time, but I can be quick. But today, if you really want to build this, if you feel blockchain is something for me, I want to build some kind of a proof of concept. When you really want to build today, there's a lot of hurdles you have to face. So first of all, there's too many blockchain technologies. You don't know which one to use, and the performance is really poor. And like Bitcoin only has 7 transactions per second. Ethereum only around 20. And there's no open standard, there is no common architect. So this is the problem that today's every blockchain developer has to face today. And what ArcBlock does is ArcBlock tries to build a solution that we create one of the open protocol called Open Chain Access Protocol. It's an open standard. We also try to open source it. So with this kind of Open Chain Access Protocol, you can access different type of blockchain with a unified query language. Right now, today, we already support Bitcoin and Ethereum, and we adopted one of the new query language called GraphQL from Facebook. Facebook invented like 4 years ago. We also built this microservice. We also built this microservice architect. We call this blocklet. So basically, that essentially you can develop those kind of event-driven blockchain applications that can be hosted in different kind of cloud platforms. We have this concept called cloud on top of the cloud. today there's many different types of cloud computing platform, AWS, Windows Azure, and IBM Cloud. For blockchain, it's a kind of very high-level protocol. It's pretty easy. It's much better to have some kind of application logic that you can decide it. I could run in-house, I could run on cloud A, I could run on cloud B, or I can have a hybrid mode. Right? This could potentially be really valuable for the military because you probably do not want to have everything public, but you do need to publish something and do need to share something. And I think I can skip a few other slides right now. Basically, it's talking about a few key components we have built. And something great is, as a startup, we always be very agile and very fast. And we started from last year, and right now, what I'm talking here is not just the kind of the architect, it's something that you can really try. Go to our website, and you can immediately try to build some kind of blockchain applications directly against Bitcoin and Ethereum. And now I will open for questions.
Oh, great. Thanks, Robert. So a round of applause for Robert. Questions for Robert? Blockchain 101. What resonated with you? What questions you have? Fire away.
A couple quickies. Does the node have to stay online in order to maintain its trust?
Sorry, question.
Does the node have to stay online in order to maintain the trust?
The question is, does the node need to remain online? Right? So it really depends on what kind of a blockchain itself. I think, for example, for the Ethereum and the Bitcoin, because it's about money, so the nodes who do the verification need to be online all the time. And but for some other user scenarios, let's say, for example, there's an IoT, it's an Internet of Things solutions. It might be the nodes not necessarily to be online all the time. It could be. It really depends on how fast you need to form the consensus. So for today's most of those blockchains, if you need to reach the high performance, some of those key verification nodes need to be online.
I just see a great application. We've been talking about acquisition and how we have stacks and stacks of paper that the KOs, our contracting officers, have to, procurement contracting officers have to maintain. If they use this type of ledger where every piece of paper is in there and every transaction, every email is all stacked in there, blockchain, your signature, everything that you've done is already in there, filed away. You don't have to print it, you have to keep it in a file anywhere. It's already contained and verified, and there's no further proof. It's all there.
Yes. So basically, my understanding of those military mostly from Hollywood movies, right? But I think some of the movies can perfectly explain what the decentralized vision is. Right? I don't remember which movie it is, but it's basically it's talk about a submarine. It has to be in a radio silence. Right? So before it radio silence, you need to imagine this is a decentralized system. So there's something download to the submarine, and then it runs like its own. It's basically before it gets synchronized with the whole node, it basically can run its node. It basically has this command, have its rules, all be verifiable, even if it's offline. So this is basically the decentralization versus centralization. So right now, for many of those kind of IoT, it all depends on the cloud. When the cloud is done, you basically lose the control. But actually, for many of them, you don't really need to talk to the big brain all the time. Each of those nodes should be able to make the decisions. So it really depends on what kind of application it is.
So how does this system handle mistakes? So let's say I put all my contracting paperwork in there and there's a typo or something wrong, it needs to be changed, I can't because 51% of the people have to approve it. So,
so that's actually a very good question. Today, especially today's 2.0 blockchain, for those smart contracts, like in Ethereum, so you cannot change the contract. So they basically call it that code is a law. So there's a very interesting incident called DAO hacking. So they basically build this kind of smart contract. They announce that the contract is, so the law is coding the law. It's not the contract itself. And then some kind of attackers try to attack it because they find a bug in the code. And those attackers basically be able to attack the code and steal hundreds of millions of dollars value of the crypto. But the hackers actually, they're not hackers. They're actually hackers actually executing the code. Right? So this is today I think this is essentially still the problem. That if you have some smart contract which has a bugs, you have a problem, and that could potentially become a problem. And the 51% attack, I think that's a different issue. If it is government or if it is just a few organizations, probably the 51% attack doesn't necessarily need to exist because this is kind of a blockchain that is still has permissions. It's a permission based. So the 51% attack is mostly talking about the public chain. Basically, it's permissionless. Anybody can participate. So the attackers, if they have a lot of those kind of computation powers, they could potentially control the chain. The logic behind that is basically they think, in the blockchain world, people think, if most of people think this is A, and it's basically all consensus-based, it's not completely based on the rule or something black or white.
Trust the data, trust the group that's coming together.
Yes.
Any other questions for Robert? Any saying on those?
Just throw one comment, and just to kind of translate this to a Navy perspective, some of the things that the Navy and the military are looking at for blockchain, because it creates a secure, immutable record, right? So you can think of turning supply chain management kind of into like a police chain of custody. So if you have high-value things that you want to do supply chain management of, you can use blockchain, and it's a decentralized system, so it's really efficient, right? Because, think of all the different places where things are going, right, in supply chain management. Other things are, because you have an immutable record, think about the times when you want to know exactly who accessed information when. So think about like international intelligence sharing. Like it could be really important to know exactly who accessed something at the same time. I just saw, I think yesterday or today, NavAir actually just announced that they're working, trying to develop supply chain management through blockchain. Think also of in-theater additive manufacturing. If somebody back stateside kind of creates a file to additive manufacture a critical part or component or something in the field, you want to be really sure that the file arrives at, on your ship or wherever in theater without having been hacked and transferred, affected along the way. So, this digital thread, you can secure this digital thread to make sure that the file that you created to, your 3D printing file is what actually ends up on the ship. There's lots and lots of applications in the Navy space, and we can kind of talk about it more, but I just wanted to translate, because this is a great presentation of kind of the generations of blockchain. But there's a lot of people that are looking at it. It's all in the proof of concept stage for a lot of this, but there's a lot of people looking at it from a military context of how they can transform operations with it.
So to the question of just correcting a mistake, can't you just resubmit another document, say for example, and that with the correction, and that will continue the chain from a trusted?
Yeah. So in this kind of particular question, imagine for example, in a blockchain like this. So once if you upload some document which is incorrect. So you're not going to be able to modify that anymore, exactly. But you can have a new version, and then it will be transparent. People will see you made this mistake, and then it has been changed. Okay. And so that's it.
Corrects the ledger, updates the ledger.
Yes.
Okay.
Robert, thanks so much, man.
Thank you.